Hi, my name is Ryan Moore. I'm from Texas A&M University, and this is my Chem 120 project over boiling point elevation. Boiling point elevation is the term for the phenomenon that the boiling point of a solvent will be higher when a non-volatile solute is added to it. This is due to the solute lowering the vapor pressure of the solvent. This can be described by the equation the change in the boiling point equals the Van't Hoff factor times the molar boiling point constant times molality. The Van't Hoff factor is the number of particles each solute formula breaks apart into when it dissolves. Salt breaks apart into Na plus and Cl minus and has a Van't Hoff factor of 2. Sugar is a covalent molecule and only has a Van't Hoff factor of 1. We expect water's boiling point to be 100 degrees Celsius. We're going to be testing a 0.1 molality and 0.2 molality saltwater solution versus a 0.1 molality and 0.2 molality sugar water solution, and listed are those expected values. First, we will start by calculating the necessary grams to make the solutions. The first step of the experiment is to zero the scale. The next step of the solution is to carefully measure out the amount of salt or sugar needed. Here I am doing the 0.2 molality salt trial. Next, you want to put the pot on the scale and then zero the scale. The next step is to measure out a kilogram of water so we can easily obtain our desired molalities. After adding the solute to water and making sure it all dissolves, you're going to want to boil the solution and take a note of when the solution begins to boil. With all experiments, our expected values are not going to match our actual values, and this is what we got. Quite a bit different from our expected values. Multiple limitations contribute to us not getting our exact expected values, such as the accuracy of our scale and thermometer, the fact that we use the ideal Van't Hoff factor, which only applies to very small molalities, we use tap water, and human error is possible in any experiment.